SwiftUI is a big and complex framework, and although it's lots of fun to work with, it's also got a lot of scope for making mistakes. In this video, I'm going to walk you through 8 common mistakes folks make when they learn SwiftUI. Some of these things are simple misunderstandings, and again, SwiftUI is big and complex, so these are easy to make. Some of these are about getting a deeper understanding of how SwiftUI works, and some are signs of legacy thinking. This is the way you solved it in UIKit, and you try and solve it the same way in SwiftUI. Or perhaps you've written lots of views, lots of modifiers, and haven't taken the time to slim it down when you've got your desired result. Anyway, not to keep you in suspense, but what my 8 are, I'll summarize them really fast. You can just skip through to the ones you care about. The first one is adding views and modifiers when they aren't needed. Second one is using observed object when you really mean state object. The third one is putting modifiers in the wrong order. The fourth one is attaching property observers to property wrappers. The fifth one is stroking shapes when you really mean to stroke borders of shapes. The sixth one is using alerts and sheets with optionals. The seventh one is trying to get behind SwiftUI views. And the eighth one is creating dynamic views using invalid ranges. We'll go into lots more detail of those in just a second. But first, I want to thank Instabug for sponsoring my site this week. They've got an amazing new application performance monitoring solution. So you can look out for network hiccups or UI hangs or more on production devices, on users' devices directly. It's an incredible way of working. Thanks, Instabug. Anyway, let's get into it. Adding views and modifiers where they aren't needed. This is our first problem. And this is one of the most common, in fact, because you're basically writing more SwiftUI code than you actually need to write. And it's common partly because we kind of write code as we're thinking and we're figuring out a problem, and it's easy to forget to go back and rethink your code and slim down and simplify your code afterwards. And again, sometimes it's a sign of going back into old habits. You're thinking like a UIKit developer or an AppKit developer and similar. As an example, if I said to you, please fill our view here with a red rectangle, you might write code like this. There's a rectangle and it's filled with color.red. And you'll see a red rectangle fills the screen. And honestly, that works great. It gets the exact result you want. But half that code isn't needed, right? You can literally just say, I want color.red and get the same result. This is because all of SwiftUI's shapes, all their colors, automatically already conform to the view protocol. So you can use colors and shapes and more as views in SwiftUI, which is great. And you'll also see this with clip shapes. You can say to someone, I want to have a rounded rectangle here. They might say, okay, I'll do color.red. I'm thinking ahead here, but I'll then do a clip shape with a rounded rectangle, corner radius of 50. So round the edges of my rounded rect. And it's complaining for some random reason. Corner radius, there we go. Not corner size. Boom, my mistake. And it'll round the edges like that, and that's fine. But again, it's not required. You can literally simplify your code dramatically by just saying, I want a corner radius of 50 and get the same result, or 150. It works identically. And obviously, removing this redundant code takes time because you've got to kind of shift your mindset a little bit. It's also harder to do when you're learning SwiftUI because you're still figuring things out. So don't feel bad if you're using the longer versions while you're learning. But when you're more advanced, perhaps think about simplifying your code a little bit to get the easier results. The second problem people hit is using observed object when they mean state object. And of course, SwiftUI provides us all sorts of property wrappers like @state object, @environment object, and more. And knowing when to use each of these matters. If you get it wrong, you'll have unexpected side effects in your program. The first one's straightforward. @state, that's a value types only. It's owned by the current view, not owned by somebody else. So that's integers, strings, arrays of stuff, and more. They're all great candidates for @state. But the other two, observed object and state object, that are very commonly used, cause confusion. Which one should you use? And you'll often see code like this. Some sort of data model that conforms to observable object. With inside there, let's do @published var username. I'll just default to 2 straws. save some time, and they'll have that in their content view like this, at observed object var model equals a data model, like that. And then go ahead and use that in your body somehow. I'll do text model dot username, boom. And that is gonna work most of the time, but will occasionally randomly fail. And I can tell you now, this is categorically the wrong modifier wrapper to use here. You should absolutely across the board be using @state object when you create your data in the view like this, because this state part, like @state and @state object, means this view owns the data. This view creates and manages the data. And when you say @observed object, you're not getting that ownership. Someone else should create it and pass it over to you, and they will keep it alive for you. And like I said, it's going to be really annoying because this code's going to work most of the time. But you'll suddenly find when you push views onto navigation view or whatever you want to, and come back to the root view, your observed object's gone because SwiftUI has destroyed your view and did not keep the model alive. So watch out for that. When you see @state, it means this view owns the data. So @state object, when you create it, observed object should be used if you aren't creating it, if you're just passing in from somewhere else like that. The third mistake, folks, hit is putting modifiers in the wrong order. Let's clear up our code just slightly. This is sort of it's a problem that will cause your layouts to look wrong, but might also cause them to behave poorly too. If you've really got your gestures in the wrong order, for example, who knows what will happen. And we can say the sort of canonical example of this is like text hello world with a nice large font so you can see what I'm doing, and a background color. I'll do green and some padding. And this is sort of the canonical example of modifier order mattering very much in SwiftUI, because here we are applying the padding after the background color. And so the color will not be applied to the padded part of the text. It'll be applied directly to the text view itself. So we're applying the padding after the background. And if you want both to be green, of course, you should switch them around. There we go. Put the background after the padding like that. So add the padding first, then color the resulting view. And that's the result you'll get. And this comes particularly interesting when you try to adjust the position of views. For example, if you use the offset modifier, this changes the location a view is rendered, but doesn't change the underlying view geometry. It still is where it was originally. It's just drawn somewhere else. And this means any modifiers applied after the offset act as if the offset never happened. We can try this out. Let's keep hello world and large title. I'll then say there's an offset x of 15, y of 15, and then our background color green again. And look at the end result. You can see it's offset the text here, but the background color hasn't moved because this thing is backgrounding the original geometry of our text, where it was originally. The offset here is only changing the rendered position of the text, not the geometry. And so if you swap offset and background, now the whole thing gets offset. But notice there's still this sort of line around the geometry of my text. It's still any other modifiers will be placed there and not in the offset location. Alternatively, the position modifier changes the location a view is rendered in its parent, but it can only do that if the parent is very, very large. So it places your view inside a flexibly sized box and then positions it inside that flexibly sized box. And again, we can see this with our background color. We can say background color green and then position, and I'll say 150, 150. And now you can see there's our text with background color, and it is 150, 150 from the edge, sort of centered here, like that. So it's working correctly, you'd think. But it's actually made a flexible frame around it. And you can see a little hint of that up here, this purple line just about to see the top here. If you were to switch position and background, you'd see what's really going on. Boom. So you've now got a full screen green view with a black hello world there. And this is exactly what's supposed to happen. Again, saying position X 150, Y 150 has to create a flexibly sized view, which will fill all available space at our purple line around the text, so it can put the text inside that view correctly. And then we're saying background color green to the flexibly sized frame, which is why the whole screen appears green. Now, although this happens, regularly, it's important to understand why it's happening, because every modifier you apply, like position and background and others, padding, will wrap your current view in a new view, a modified content view. Some don't. Changing the foreground color or font in some places will bubble through as a preference rather than a new view. But the vast majority will wrap your content in a new view. Offset, for example, position, background, they'll all place your views in new views each time. And this is actually a powerful feature. And yes, it means it's painful sometimes because your modifier order isn't quite right, but it allows you to do interesting effects that would otherwise have been very hard, because each modifier is applied to a new view every single time. We can say font large title, then add some padding, then add a background of color.green, and then add some more padding. Wrap that in a new view, and then give that the background of color.blue. So you can stack up modifiers again and again and again, which you wouldn't be able to do if these were simple method calls modifying the same thing directly. Whereas they create new views, you can do this. You can also say, I want to deepen certain effects. I want to have a hello world here, but I want a foreground color of white, and apply a shadow to this using color lowercase c, color dot black, and radius 10. You see a shadow like that. But because every time you call shadow, you get a new view back, we can say shadow, 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 and get a super deep shadow like that coming back. Much thicker. Okay, the fourth thing I see folks trying to do is attaching property observers to property wrappers. Let's clean up our code a little bit. So there are some situations where you're able to attach a property observer, did set, will set, to property wrappers. But often this just does not work as you'd expect. For example, if you had a slider, let's say we have at state private var rating is 0.0, and then a slider here with value $rating. You'll slide down, it'll change the binding. That's what it's doing here. But if you want to watch this changing and run some code as it changes, you might try and say did set print rating changed to rating, like that. But if you run that code back, you're going to find nothing happens. Yes, the slider will work, but nothing's being printed out into my debug console down here. It is not doing what you expect. And the reason is because the value is being changed directly inside the state property. You're not actually changing the state struct wrapper around it, changing the internal value only. And the SwiftUI native approach to this, to fix this, is to use the onChange modifier. So you'd sort of scrap this code here. No more did set. And instead say that my slider has an onChange of rating. Bring the value in and then just print out rating change to value like that. And that will now watch the rating value if it changes. And when it changes, it'll print our code out. So here you go. Boom. So that's the way SwiftUI wants us to do it. I personally prefer a slightly different approach. I use an extension on binding, the binding struct itself, that gets called when the wrap value changes, but also calls a handler function of my choosing. And I'll show you how that works really fast. You can say there's an extension on binding with func on change, takes a handler, which is escaping over whatever the value of the binding is, returns void, and returns a new binding over that value. And inside here, we can say return a binding where the getter is self.wrapValue. That's easy enough. And the setter takes a new value coming in. We'll assign that to our wrapped value. And then call our handler function on the new value, like that. And I find that easier to work with because we can now isolate our code more clearly what we're writing. We could say, there's a method down here, slider changed to value double. I'll just go ahead and take this thing here into there and get rid of the onChange entirely. And instead now say slider value $rating with dot onChange slider changed. So I attach my method directly to the binding being used in the slider. I find that significantly easier to think about. And it'll do the same thing as you're dragging it around. But it's just, there's no more onChange, onChange, onChange as modifiers. It's directly in the binding. This thing, when this changes, run this, and so forth. So you could say when the slider changes, do this. When something else changes, do something else. As opposed to all going through the same rating onChange modifier. Use whichever one works best for you. Number 5 is stroking shapes when really you mean to use stroke border. Let's clear up some of this junk from here. So when you're drawing shapes, it's really common to want to stroke around them, but this can cause all sorts of problems. If you said, I want a circle with a stroke of color.red and a line width of 20, when that runs back in my canvas, you're going to see the circle here. But notice how the left and right edges of our circle here and here are clipped. You can't see the edge of the circle. And this is because when you ask for a stroke to happen, in this case it's 20 points, that stroke will happen centered on the edge of your shape, which in this case, of course, is our circle. It goes to the very edge of the screen, to the very left and the very right here. And when it draws the line, it'll draw half of it outside that edge and half of it inside that edge. So it'll be centered on the circle itself. And sometimes that's what you want. As you can see here, it's causing problems. A better solution most of the time is to say, I want a stroke border, which means stroke the full amount inside the shape. And so our circle's still the same size. It still goes edge to edge here on the left and right sides. But now the stroke is drawn inside the circle, which is much, much nicer. There is one time when stroke versus stroke border is, stroke's a better choice here. And that is when you're using a stroke style. If you look at stroke, you'll see there's loads of options here, and so many of these return a view here, loads of views come back, but a handful on stroke only return shapes. So stroke does, stroke style does, and stroke line width returns new shapes, not views, which means you can create certain effects that would otherwise be impossible, such as stroking a shape twice. For example, if I said I want to do a stroke with a style, and my stroke style was a line width of 20 and a dash of, I'll do an array of just 10. You get that. If I then said you've got a frame with a width of 280 and a height of 280, boom, I can actually apply this stroke twice because it's using the stroke style modifier, so we get back a new shape. So I'll just copy and paste that stroke like that, and we get an interesting sort of railroad effect. It's great. And you couldn't do that with stroke border because you get a regular view back, not a shape. So you couldn't call stroke twice. Most of the time though, stroke border. Number 6 is using alerts and sheets with optionals. This is the recommended solution to a problem folks have many times. When they're learning to present alerts and sheets, it is very common, in fact, very normal to take a simple approach, the easiest possible approach, which is to bind your data to a Boolean. So let's say something like this. There's a struct called user, which is identifiable. There's an ID for that. And inside our content view, there's one @state property, which is called selected user, which is an optional user. And another @state property, which is showing alert, and that is false. And then in our VStack, our body style down here, sorry, we'll make a VStack. And I'll make this VStack have a single button saying show alert. And when that's pressed, I'll make our user equal to a new user with the ID of @2straws. And I'll make showing alert equal to true. So we'll show the alert. And we can now bind that to a simple alert by saying .alert modifier using isPresented. And this will be $showing alert. And the content is going to be alert with a title of text, hello, selected user, forceunwrap.id, like that. So we've got this Boolean, is the alert showing or not, plus a user to set. When the button's pressed, make a user, show the alert, and here, show the alert and show the user ID. I'll press Command R to build and run that code. And I press this button here, boom, hello, 2straws. So that works great. And honestly, it's the easiest way, I think, to learn alerts. Is it showing true or false? But once you're past the basics, you should consider, if possible, moving across to a different form of alert, which takes optionals instead. Same for sheets. And these let you remove the extra Boolean entirely, plus remove the force unwrap. But it has a single requirement, which is whatever item you're presenting must conform to identifiable, which our thing helpfully does, not entirely by coincidence. For example, we can show the same alert by ditching this Boolean down here. Go away. Ditching it being set down here and just set selected user directly. And instead say item $selected user. Watch that for a value and pass in that user when it's set. And now here we can just say user.id. So we're saying watch this value here whenever it changes. And as soon as it changes, becomes not nil or changes from one value to another value, whatever you want to, call our alert, pass in the unwrapped version of that optional, and use it inside our alert. So it makes your code simpler to read and write about. Obviously, it still works great, but it also removes the extra worry of the force unwrap. If you've done things slightly wrongly, things weren't quite as you thought, that's no longer an issue. Number 7 is trying to get behind your SwiftUI view. And this is a really common problem people hit when they're learning. They want to change what's behind their SwiftUI view. And it usually starts with code. Let me get rid of this junk again. Code that looks something like this. Text, hello world, .background, color, .red. And they expect this thing to fill the screen with a red background color. And it doesn't, as you can see, it's a white background color down here. And it's going to fit tightly around the text, which is very annoying. You want a red screen, you actually get a white screen. And so they start thinking, well, what's behind my content view? How can I set that? How can I give a background color to the rest of the screen? And they might, go into the app area here and try and dig around with their window group, for example. Other folks might go into UIKit territory and dig around there. And yes, of course you can do that. Behind our view, if you run it back in a simulator, you can dig through it and have a look and see what's there. And yes, there is a UIKit view controller behind this. Boom. This hosting view controller, a UI hosting controller, and it's a regular view controller like any other. It absolutely works. You can dig into that and find it and modify all you want to, but you might find your SwiftUI code starts behaving strangely. Or you might try and move your cross-platform SwiftUI code to macOS or to watchOS or something else where UIKit doesn't exist. And that's going to cause problems to you in the long term. So try and think like SwiftUI. If that is the only part of your content view, then make it fill the screen. Say this thing should have a frame with a max width of .infinity and a max height of .infinity. Let's even add ignores safe area, so it really fills the complete screen. If that's what you mean, say it. Remember, your content view itself doesn't really exist. There are no properties here. Has a 0 size at runtime. It just calls the body property and puts this onto the screen inside the hosting controller. That's all that's happening. And the last one is creating dynamic views using invalid ranges. And this is actually quite common because several of SwiftUI's initializers have these slightly easier versions that let us pass ranges, which is really cool. It makes all sorts of layouts easy to create. For example, if you want to show a list with 4 items, you might say something like this. Var row count is 4, and then have a vstack list 0, 2 row count, row in, text, row. And that works great. Honestly, that kind of code works fine. Do that. Use the easy adapter thing here. But it becomes a problem if you try and change that range at runtime. For example, if I had made row count at state private var row count, it can now be changed. I can now go inside our vstack and say there's a button here called add row, and when that's pressed, row count plus equals 1. Add a little bit of padding to keep it away from the top bar, like that. And if you run the code now, you'll see Xcode issue warnings to you. I'll press add row, boom, big error, don't do this, it's only for constant data. And in fact, it hasn't even added a row. It just does not work. So don't do that. To fix this, you should always make sure your list or your for each is bound to identifiable objects or provide a specific ID. Even if it's the same idea what it had before, it's a specific idea to work with. And this makes it clear to SwiftUI this is going to change. So here we might say 0 to row count with ID of \self. Use those numbers 0, 1, 2, 3, in this case, plus whatever we add in the future, as the unique identifiers for our views. And now adding row will work correctly. So it actually is a much better idea. So I hope you found this video useful. No matter how much SwiftUI experience you have, as I've said several times, honestly, some of the alternative code I've shown you, the sort of older way of doing things, works great. And although, yes, you can improve, it's okay. There are always things you can improve. And if you're just learning SwiftUI, then don't get hung up too much on whatever code helps you get stuff done. Once again, I want to thank Instabug for sponsoring this. Go and check out them out at instabug.com, but also have a look at their application performance monitoring solution. It's very impressive. And if you enjoyed this video, subscribe, hit a like button, leave a comment. Tell me the kind of mistakes you made when you were learning SwiftUI.